Hey guys, welcome back to chapter 14. In this video, we're going to work an example, and then I'm going to share with you how to go backwards. So kind of another example, but it creates a teachable moment. So here is the first example that we're going to work on. Go ahead and pause the video and see if you can solve it yourself. All right, so calculate the pH of a solution that is 0.0015 molar of strontium hydroxide. Determine if the solution is acidic, basic, or neutral. So the first thing you guys need to recognize is that this is a strong base. How do I know? The hydroxide is a really good indication that it's a base. And then strontium is a group 2 metal. So hydroxide, group 2 metal, that's a strong base. To get to the pH, we're going to first calculate the pOH and then get ourselves to pH. So pOH, again, is the negative log of hydroxide concentration. With this being a strong base, I know that the hydroxide concentration is the same as the concentration of a strong base, but I've got this 2 to consider. Okay? So when determining the pOH, we're going to take the negative log of 0.0015, and I have to multiply that by 2. So for every one of these that breaks apart, 2 of these are created. Okay. So the pOH in this case would be 0.0015 times 2. And then I'm going to take the negative log of that, and I get that the pOH is 2.52. And then, as per usual, it typically asks for pH, not pOH. So I'm going to take 14 minus that number. And the pH is 11.48. That was the first half of the question. Calculate the pH. Does that make sense to us? Yes. That's going to answer the second half. So is the solution acidic, basic, or neutral? So having a pH of 11.48 makes this fairly basic. And that makes sense to me because I made the claim that it was a strong base to begin with. So to get all the points, I would write that this is a basic solution. Let's take a look at this example. So this is kind of the inverse, right? So up until this point, I'd given you the hydronium concentration or some way to determine the hydronium concentration. Solve for pH. Now we're given pH and asked to solve for the hydronium concentration. So what do we know? We know pH equals negative log of hydronium. If I want to solve for the pH, I have to do the inverse of negative log. Anybody know what the inverse of negative log might be? Yeah, we are dealing with log base 10. So the hydronium concentration is going to be 10 to the, so this is an exponent, negative pH. So these two are inverses of one another. So to solve for hydronium concentration, we would take 10 to the negative 4.8. Where did I get that 4.8? I got it from the pH. It gave me the pH. So I'm going to type into my calculator 10, the little caret, 4 to the negative 4.8. and I get a value that looks like this. (1.58 times 10 to the negative fifth). This is, remember, a concentration, so I'm going to stick the unit for molarity onto the end. So it's kind of hard to ask ourselves, does this make sense? Because hydronium concentrations don't really make sense to us. But it should make sense in the sense that it is a decimal with a negative exponent. So when we're talking about the concentrations, we've had these like really weird decimal times 10 to the negative something. So while the exact value may not make sense, it does make sense. The format of the answer is 1.58 times 10 to the negative fifth. So just something to keep in mind there. Okay. So again, here's kind of a table of helpful hints. This is probably more complete than the ones I gave you before. But pH is negative log of hydronium. If I want to solve for hydronium, that's 10 to the negative pH. We can make the same statement over here for POH. So POH is the negative log of hydroxide. Same statement. Hydroxide concentration is 10 to the negative POH. So that's kind of the same relationship there. And then we've utilized this one before, pH plus POH equals 14. So this concludes the section on strong acids and strong bases, determining the pH or POH. This is just a slide to remind you of the strong acids and strong bases. You have to be able to recognize these because we're going to start talking about weak acids and weak bases. And that's a different path that we take. It's a different route through the problem. So the first step is going to be determining, is it a strong acid or base? If the answer is yes, we use what we know. If the answer is no, it is not one of these, we have to take a different path to solve the problem. I hope you guys found this helpful.